Hi friends, welcome to SSC JE Electrical. In this video, I am going to discuss about quality factor, and majorly we will discuss about the quality factor and some portion about resonance also will be discussed. And what is the meaning of resonance? Resonance is nothing but a response of a circuit where it is operating at its natural frequency. It is a response of a circuit where it is operating at its natural frequency is called resonance frequency. In exams, what kind of questions they usually ask? See here, at resonance, nature of the circuit is, at the resonance, nature of the circuit is what? Resistive. At the resonance, nature of the circuit is resistive. And at the resonance, what is the power factor of a circuit? At the resonance, what is the power factor of a circuit? At the resonance, what happens? The voltage and current are in phase. The voltage and current are in phase. Therefore, the pi value, the angle becomes 0 between voltage and currents. Therefore, power factor is cos 0 equals to 1. Therefore, power factor is unity power factor. At the resonance, maximum power transferred to load. Maximum power transferred to load because network becomes resistive. So, power dissipated through resistor only. Okay. Resonance occurs when two similar and opposite nature energy storage elements present, that is inductor and capacitor present, then only resonance occurs. Quality of energy storage elements must be high, which is termed as figure of merit of quality factor. Regarding quality factor, quality of energy storage elements must be high. Quality of energy storage elements must be high. That is called quality factor. See here. Quality factor equals to 2 pi into maximum energy stored in per cycle of supply by energy dissipated per cycle of supply. If energy stored is high, then quality factor becomes high. Okay. And moreover, important formulas we can discuss on quality factor. Regarding quality factor, we can say that is reactive power by active power we can say. Okay, reactive power by active power we can say, reactive by active power we can say quality factor. And important formulas discuss. See here, if the resistor, for example, we are taking a resistance, that is R equals to 0. Resistance we are taking as a 0. In case of RL circuit, what happens? You see, in case of RL circuit and RC circuit, what happens? In case of series, in case of series RL circuit, what happens? The quality factor formula is Q equals to omega L by R. In case of RC circuit, quality factor is equals to 1 by omega C R. In case of RL circuit, what happens? Resistance in series with inductor. In case of RC circuit, resistor in series with capacitor. So, in this case, we get Q equal to omega R, omega L by R, and in this case, we get Q equal to 1 by omega C R. For example, if the resistance is taken, see here, only inductor taken. For example, only inductor taken, what happens? Only pure inductor given. What is the quality factor? Only pure inductor given. What is the quality factor? Q equals to omega L by R. R becomes 0. No, in this case, R becomes 0. Therefore, what happens? Omega L by 0. Therefore, infinitive. For pure inductor, quality factor is infinitive. For pure capacitor also, quality factor is 1 by omega C R. No, R becomes 0. Therefore, infinitive. For pure capacitor also, quality factor is infinitive. So, very important here. What we need to remember here is, in case of series RL circuit, Q equals to omega L by R, and in case of series RC circuit, 1 by omega C R. And in case of pure inductor, quality factor is infinitive. For pure capacitor, quality factor is infinitive. And for the same case, in case of parallel, what happens? Just inverse of that. In case of parallel, what happens? Quality factor equal to just inverse of the series quality factor only. Q equal to R by omega L, just inverse of that. In case of RC circuit, this is regarding RL circuit, this is regarding RC circuit, what happens? 1 by omega C R given, no, for series. For this, just reverse of that, that is 1 by C R, omega C R we will get. Okay. Hope you understood. In case of, important formula this is, in case of series RLC circuit, in case of series RLC circuit, quality factor equals to 1 by R root over L by C. Very, very important. In case of series RLC circuit, quality factor equals to 1 by R root over L by C. And in case of parallel RLC circuit, Q equals to just inverse of that, just inverse of that. What you will get? 1 by R root over L by C. You will get R root over C by L. Just inverse of this. When we inverse of this, we will get this one, R root over C by L. These are the some of the important formulas regarding quality factor. Very, very important. Okay. Again, I am repeating. See here. In case of series RL circuit, Q equals to omega L by R, and in case of parallel RL circuit, just inverse of that. Okay. In case of parallel, just inverse of that. Okay. Just inverse of that. Q equal to omega L by R. In case of parallel, R by omega L. In case of series RC circuit, 1 by omega CR. In case of parallel, omega CR. In case of series RLC circuit, 1 by R root over L by C. In case of parallel RLC circuit, Q equal to R root over C by L. See some multiple choice questions on this. In case of series RLC circuit, the quality factor is given by, in case of series RLC circuit, quality factor equals to Q equals to 1 by R root over L by C. Just now we discussed Q equals to 1 by R root over L by C. In case of parallel, what happens, you see? In case of parallel RLC circuit, what I told? In case of series, what we have discussed, 1 by R root over L by C. In case of parallel, what happens? Just inverse of that, 1 by R root over L by C. When we inverse that, what happens? R goes to numerator, so R root over C goes to numerator, so R root over C by L we will get. R root over C by L given in B option, so B is the correct answer. Okay, these are some of the important multiple choice questions on this quality factor, and whatever we have discussed regarding this quality factor, in case of pure inductor, pure capacitor, that is also very, very important. Okay, in case of pure inductor, pure capacitor we have discussed, and for series RLC and parallel RLC, and for only RL, for only RC also very, very important. And moreover, regarding relation, very, very important, regarding relation, bandwidth and quality factor relation will be there, no, that is also very, very important. You see, regarding quality factor and bandwidth is very, very important. Quality factor is equals to resonance frequency by bandwidth, very, very important formula. Quality factor equal to resonance frequency by bandwidth, very, very important relation. Okay, when bandwidth decreases, when small bandwidth, large quality factor. Okay, when the bandwidth is small, large quality factor. And one more here, quality factor is proportional to selectivity. Quality factor is proportional to selectivity, particular portion of frequency only we are selecting here. So when selectivity increases, quality factor also increases. Okay, see here, when small bandwidth, large quality factor, higher the value of quality factor, smaller the bandwidth, higher the selectivity. See, in this first case, you see, in this case bandwidth is very small. When bandwidth is small, what happens? Q becomes large, greater quality factor and greater selectivity, we can say. Small bandwidth, greater quality factor and greater selectivity. And large bandwidth, for example this one, you see, large bandwidth of frequency we are taking, then what happens? Smaller the quality factor and smaller the selectivity. Okay, inversely proportional, very, very important relation this is. So small bandwidth, large quality factor, large bandwidth, small quality factor, very, very important relation. Okay, and quality factor is proportional to selectivity, very, very important relation. So this is regarding quality factor, majorly quality factor we discussed, and some portion about resonance we have discussed. And thanks for watching this video. Please like this video and share this video with your friends, and don't forget to subscribe this channel for more videos. Thank you.